Oh, wow. Okay. Well, something happened. Well, was my video always off, or is this the first time I just came on the screen? Did I? So was my video off before also? Oh, it was. It was. So I never switched it on. Okay.
It
All
was
right.
on at
Thank
the
you.
very beginning. It was on at
Oh,
the
it
very
was on.
beginning. I think you accidentally just hit it. I don't think it's related to the recording.
Okay. All right. Okay. Thank you for that. Great. Great. Okay. So Chinmay, Jim, Adam, Rohan, Manguan, and Eileen. Okay. I think a few more people may join, but you guys can just feel free to start talking amongst yourself if you want. Unless you have any specific questions for me, I'm happy to answer them. Otherwise, I'm just going to hand it over to you guys so you can have a free-form conversation. As usual, as before, just no sharing of specific mini quests or tips for specific mini quests, but concepts are perfectly fine. In fact, even you can even work on code. Okay, so if you have a certain mini quest that's not working, you can abstract out what it is that it's testing, and then you can do a separate program, a main with doing exactly that, throwing exceptions or freeing pointers or things like that. You can do that on screen. You can say, I'm going to share my screen and I have a piece of code here that's not working. Can we debug it together? Fantastic. Okay, so debugging code together is fantastic, except that we should not get sucked into the temptation of debugging all code together. I think that's why our quests are proving to be quite useful, I think, because as a student, you're going to be writing tons and tons of code. And it'll be unrealistic to say none of that code is supposed to be debugged with other people. No, some of that code, obviously, you need to have the experience of coding together and debugging together. But at the same time, you also need to have the experience of coding on your own and knowing when to ask. And so usually it's a sign of beginning programmers that they ask too soon. And I've had even hires I've had who just came bursting into my office one day and said, hey, you know what? I discovered a flaw in GCC. All right, I discovered a bug in Microsoft Visual Studio because my code is perfect, but it crashes if I compile it with GCC. So there must be a bug in GCC, and the Microsoft engineers are bad. Okay, it's possible. There's a remote possibility of that happening. But how likely is it, right? We are beginning programmers, and these guys have been coding for years and years, and that code has been read by millions of pairs of eyes. So how likely is it that the error is there? So I think the more experience you get, it's not only that you will, this is my theory, it's not only that you will have less need to ask other people quickly, saying, hey, what's the problem? How can you help me? But you will recognize there's a whole bunch of problems I can talk to other people with, but this one is mine. Okay, I'm not going to share this cake, right? This cake is only for me, and I'm not going to ask other people. I'm going to try and solve it however long it takes. I don't care, because I've got the password. I can move on, but I'm going to come back here and do it because this one is for me. And so the passwords have been set up in such a way that there's always a bit of every quest left for you to come back and noodle on after the course is finished. You can come back and try and do this, because that's where the real nuggets of computer science are. And knowing when to ask other people, knowing when to say, this is a problem in my code versus this is a problem somewhere else. Yeah. And you can also, I think, exercise the more likely scenario judgment, that if you're working with a program that has been that's being used by many people, like compilers and all, right? Usually the problem is with our code. And you can go to Stack Overflow and other places, and you can also check. Many people will say, hey, is this a problem with GCC? Is this a problem with Visual Studio? And you'll see answers saying, no, it's not a problem with Visual Studio. It works. Maybe this is the area you should check, and so on. But however, you shouldn't make that post, okay? Don't make that post. Don't contaminate your Stack Overflow and other online profiles. Just keep it squeaky clean, professional, because by the time you finish everything, and a prospective employer says, hey, you know what? Someone employed here. Let me go and Google their name and find out what they've been up to online, right? Because if you're applying for a programming position and someone Googles your name and nothing comes up, it's very unlikely that you might even be called for an interview. So you need to have an online presence, which means that you also need to curate it for a certain level, and that way you can make sure that even as a student, you're actually doing all the right things by saying, if there's a problem, I'm not going to blame someone else. I'm going to see if this problem is in my code first. And that kind of questioning, even if the problem is not in your code, okay? So that is a cool thing. So even if the problem is not in your code, and you ask a question about, hey, you know what, I'm using the open GL library or something to do some graphics, and this line is not being shaded, this surface is not being shaded properly, okay? This is a shadow here that I don't even see, right, for the object. So where is it coming from? And you can ask that question instead of saying, well, in open GL, there's probably some artifacts. So if I do some complex stuff here, it introduces, artifacts because artifacts in graphics programs are very common. Yes, because even when you're writing your own graphics routines, you'll find that everything looks okay, but there is some dots here. There's some, this line is not perfectly straight, or there's a zigzag that I didn't expect to be there. All of these are artifacts that are giving you what you want, but not perfectly, right? Because there's a bug in the rendering, bug not in the logic, but okay, logic bug that is showing up in rendering. But because it's graphics, sometimes you may not even see it, right? Because you'll only see it, you may run tests on a small screen like this, right? But in a production setting, that'll be tested in 4K, 16K environments. There's huge, high resolution photographs and things like that. And there it may show up, because there's a bug that doesn't show up in small scale, but it shows up in a large scale. And so graphics programs, artifacts are very common for if you write your own graphics routines. But the thing that we have to keep in mind, especially as you're going to be doing game programming and all these other things, we're going to be writing a lot of graphics code. Obviously, you don't have to write the bare bones graphics code these days, because all of these are in the libraries. Chances are, I think, 10 plus programmers, okay? I don't know, I'm just pulling a number out of thin air, okay? If 10 plus programmers do something in C++, in an SDK, right? Not in C++, in native C. Download an SDK, whatever the SDK is, right? Or OpenGL, Unreal, whatever it is. 10 plus programmers try to do something and say, I had to do this in order to get it to work, and they post on Stack Overflow. You can bet that in the next release of the SDK, that will be turned into an API call, right? There will be a library function that you can call to do that. And that is why, and not only that, because it'll be turned into a library function that immediately, as soon as Unreal or OpenGL releases it, immediately, tens of thousands of programmers around the world, they'll immediately use it, okay? Because they've been using some routine they've put together, and they're saying, if only there was a general purpose call, I would use that instead of having to do this. Because even if your code works, if it is contributing 5,000 lines of code to your overall code base, right? And I know that the 5,000 lines I've got to do this particular graphic transformation is necessary, and it's not available, and I've debugged it, and it's perfect, okay, squeaky clean. Even then, if the library, the manufacturers, Microsoft or OpenGL or Unreal, they say, okay, right, based on all the feedback we've got, we've implemented one function call that will do this for you, okay? And that will basically eliminate 5,000 lines of my personal code. I would absolutely happily take it. And so people who are heavy duty hardcore programmers of these libraries, they're always subscribed to these millions and millions of subreddits to do with these libraries, or they're on they're subscribed to specific feeds that say, well, latest updates from Unreal, latest updates from Microsoft, and so on, right? And they're always looking at it. Every, in the morning, sometimes in email, they may get a message saying Microsoft released, 17.5, version 17.5 of this particular OpenCV library. Okay, and what are the differences between the old and the new? This new one contains, I don't know, some, let's say, Tang and Stone, right? Tang and Stone algorithm for graphic, rendering. Okay, and that is exactly what you've implemented, right? Maybe Eileen and Adam came together sometime and said, well, this is what we're going to do in a joint project, and I want to do this. So can we cut some code together and use that? Okay, so they've done that and even published it because it's common. It's commonly needed by people, and everybody needs it. They published it even. So and then Microsoft picked it up. saying, wow, okay, lots of people are using that particular algorithm that was devised by these two programmers. So it may be useful to just take that and integrate it into the library. Okay, so the next release of the library will actually have your code in it. Well, not your code, but essentially it's your code, isn't it? Because they're going to use your algorithm and implement it. Their own engineers are going to implement it, but it's your algorithm essentially.
How do
right?
we
So
know if they implement it? Like if we upload something, and how do, like, are they going to credit us, or are they going to reach out to us? Like, will we know?
Yeah, absolutely. If you go to the documentation, right? If it is a very novel algorithm for doing something, right? If it is a very novel algorithm for doing something, and a big company integrates that into their code base, if you go to the documentation, even if you download the source code, open source, if you download the source code, you'll see it in the comments saying this algorithm is based on, Tang and Stone 2022. Right? And you'll have a link to that paper. That paper is probably linked in some open journal. You can click on it and read the paper and find the algorithm. So even now, you download any of the toolkits, you can see this documentation everywhere, right? And also, it is also a good sign to, if a big company picks up your algorithm and integrates it, that's a sign that your algorithm will actually solve it. Because otherwise, they wouldn't do it, right? They'd say, yeah, okay, it's simple enough, anyone can do it. Yeah. So that is a great thing to actually work towards also. Because
have you had stuff picked up by companies?
Yeah, various things. But yeah, mostly in research. Well, maybe also outside of research. Some things I've actually forgotten. But mostly, but a lot of stuff was to do with language modeling and natural language processing. And the Siri, for example, right? Siri, we developed Siri in SRI. And I remember the very first version of Siri that was put together. I did it because the Adam Chire, he was not Adam Stone, Adam Chire. He was in the AI center at that time. I was in the speech lab. And he was working on his baby, because he had been doing that for ages, open agents, right? Essentially a way in which one program can talk to another program. They're different programs. Right? And today it's all very simple. You see API calls and REST calls. You can just, you can have machines that are distributed all over the world, and you make REST calls and get the results. But back in that day, back in that time, REST wasn't a published API. REST is the API paradigm for two HTTP servers to talk to each other, right? Or a client to talk to a server. And so Adam was very passionate about that. And he said, if you have multiple services, then we can use this kind of interacting between computers, between different programs, to put together a bigger program that uses these guys as services. So he came up with an incredible framework back at SRI called an open agent architecture. I think it was called OAA. Right, so he was developing that in the AI center, and in the speech lab, I was developing. This was back in the early 2000s. Early 2000s, you couldn't interact with machines by voice. Today I can say, hey Google, what's the time, and it'll basically just tell me, right? Why didn't it tell me? Hey Google, what's the time? Okay.
It's 10:16 a.m.
Okay. All right. Okay. It didn't get it because the reason why, I think, this is my theory, the reason why it didn't get it was because when I said, hey, Google, what's the time? It was actually closely juxtaposed to the remainder of the previous part of the sentence. Therefore, that occurred inside another utterance spoken by me. And because it was not preceded by the start of line character, which is the beginning of the line, it was not detected with high probability by the language model that is used to traverse the graph to determine what I spoke. I don't know. Does that make sense? This is how we do speech recognition. Well, in those days, now these days, I don't know, right? These days, we rely on a lot of probabilities encoded inside a deep net to figure this thing out. But back in the day, this is how speech recognition evolved. So I put together a system where this is that time, ringtones were all the rage. Okay, people would develop ringtones, stupid ringtones. Okay, so C D E F G A B, like that. Okay, play it on some violin, record it, and put it up there, and people would pay $2 to buy it. Right, and even some random song like Katy Perry or some U2 or something like that. They turn some popular phrase into a ringtone, and they were making killing huge amounts of money, because if a ringtone was only $1.99 and a million people downloaded it, which actually was true, because a lot of people with cell phones at that time were downloading ringtones like crazy. It was a huge business. So but then the companies were facing a challenge regarding how to market these ringtones, because they were getting tons and tons of ringtones submitted by people, and they need to market it, because when people buy a ringtone is when they're going to get a cut of the profit. And so Doug Burko, who was the business guy at SRI I was working with, and he said he did some research. Okay, he did some research, and he found that if you want to buy a ringtone, you have to click on average 20 times. That's not on the iPhone, okay? This is on the old Motorola phones, where you have to press the numbers, okay? Press 1, press 3, press 4, that menu option. So he said 20 clicks to buy a ringtone that you want. So let's calculate the proportion of users that drop off at each click, right? Saying, well, I've done 5 clicks, well, it's not worth it anymore, so I'm going to go, right? So there is a user drop off at each click. And so he said, let's calculate those things. And he was a business guy, right? But he still, went ahead and calculated these things and said 20 clicks, you're only going after 2% of the market or 3% of the market, because most of the people have dropped off. You're only selling to the people who are really determined to buy that ringtone because it was, composed by their brother or sister. Okay, so and so he said, well, is there an easier way for companies to buy, for people to buy ringtones? And I said, let's. I said, and I ran some experiments at that time. And said, well, okay, it's actually easy to buy a ringtone if it's the top 10 most popular songs. Right? You can get the top 10 from most of the radio stations, or even top 1,000. Right? Download the top 1,000 and build a language model over that. You can recognize that with super duper high accuracy. So you can say, download A Whiter Shade of Pale by Procol Harum, which is actually the song that I use. It wasn't, in fact, it is not a top 1,000 song. Right? Do you know A Whiter Shade of Pale by Procol Harum? Right? So it's not a top 10 song. And I think it's kind of related to a Bach piece and all, but it's very nice. And not many people download it, but it's there. I think it was the top, when I looked for it back in the 2000s, it was, top millionth or something like that. Okay, so there was no way someone could ask for that. However, they could say, download Fireworks by Katy Perry, and bam, they'd get it like that, because it's a top 1 or 2, 3, 1, 2, or 3, because the language model has it. And the other one, the language model doesn't have it. So, so at that time, I put a system together, and I think it was called domain-dependent speech recognition, or dynamic domain adjustment, or something. I forget the name, right? So what it did was, it would take a language model and recognize something with low accuracy, but it will only pick out the words with high accuracy, because you can recognize an entire utterance. I say the likelihood that this entire utterance was spoken by the user is 10%, so very low, unlikely. However, now I break it down and I see, well, the likelihood that this utterance has 10 words, and the likelihood that the first word was spoken, 2%. Second word, 3%. Fourth, fifth, seventh, eighth, ninth words, there's 95%, right? And the last few words, very low likelihood. So when you take the overall probability of the utterance, very low, isn't it? Because it's a product of all the probabilities. However, what I did was I took only the high likelihood words, and then using the highly likely words, I extracted sentences from a text corpus that matched only that contained those high likely words, and built a second language model, and we recognized from the second language model. And that was like super duper accurate. And I think I called it GIG at that time. That technology was called GIG because when I built the prototype, my own MP3 collection crossed 1 gig, right? I had many songs at that time, and so I called it GIG. And then we did and SRI said, we're going to turn this whole thing, Open Agent from Adam and the speech recognition part from here, into a company, and we called it Siri. Actually, we didn't call it Siri, was a project called Kalo that was funded by the government, the DARPA actually. So we were working on it, and then after a while, after I left, that's when SRI spun off the company. It was called Siri proper, and then Adam was working on it. I think his office was in San Jose. In fact, I went and saw him there too, and And then after a while, oh yeah, actually, the day that I went and saw Adam was also the day when I think he received a phone call from Steve Jobs, and he told me later on, oh well, I picked up the phone and it was Steve Jobs, and that's when Siri was bought into Apple and integrated and so on. So I'm pretty sure there's a bunch of my code code that we developed in our lab, not only mine, the entire speech lab, that went into the company Nuance, because Nuance was a spin-off from SRI, and then Nuance was what Adam used for building Siri. And it was one of the services. And he had a natural language person, right? So I think Tom or someone was working on the natural language part, but everything was being interacted with by Adam's OAA and getting all the information at the right time. And it actually worked very nicely. So all of that code is in Nuance, and it was bought by Apple. No, it was used by Apple. I think now Nuance is, Microsoft bought Nuance, I think. So I think Nuance is not independent anymore. It's probably part of Microsoft. So
Do you
anyway,
get royalties?
Yeah.
Do you get royalties?
Yeah. Actually, how did that work? I don't know. I think it was a one. Yeah. Sometimes SRI does one-time payoffs, and I don't know. I'm not currently. I don't get any royalties, or maybe
That's unfortunate. You contributed to Siri, but it's
yeah, everybody does. Yeah, everybody in the lab does, right? Everybody in the lab does. And when Nuance was spun off, everybody in the lab got shares of Nuance, right? At pre-IPO prices, and everybody really made it big. Everybody who stuck around and in the lab, despite Nuance spinning off, they all got lots and lots of money out of that. So I think that is probably a one-time payoff, rather than saying, okay, well, the code is now integrated. Now Nuance is going to send you a check every month, right? That is more painful for a company, I think. So they'll just buy it off one time. But usually I think that's how it is. Yeah, unless the code we generate is earth-shattering, like a fundamentally new algorithm that says, you can actually sort in linear time now, or you don't have to do even log linear, which is, right? Of course, it's impossible. If you prove that it's impossible, that's really cool. I'll give you extra credit too, right? But in certain situations, it is actually possible, right? If you exploit domain knowledge, it is possible to sort in linear time. In fact, I have a quest. It's not part of the green. It's one of the fun quests, and it's called Curiouser and Curiouser. Okay, and it's not to do with sorting, but it's very related. It's an idea that's related. So if you go into the questing site and type Curiouser and Curiouser, you get to do a quest in which you got to do something in linear time, which is normally not possible in linear time. It takes log linear time, and because you got to sort and all. And so anyway, so where I'm going with that is that if you can prove something fundamentally, groundbreaking, like, light bends around massive objects, okay, and some fundamentally groundbreaking like that, then a company will integrate your code directly, because it's important enough. But otherwise, usually what happens is that they want to wait until it's been proven out there. So they'll see that is it adopted by enough people, right? Or they'll, on GitHub, is the download count greater than something? Or look at the comments. And more often than not, they'll just wait for commercial validation. So it's not just enough that 1 million programmers download it and say, oh, rave about it, saying it's really cool. It's more a situation of, well, it's really cool, but is it going to make us money? Right? So they'll wait for your code to actually make it into a product that has been bought by people generating profit for you. And then they'll buy it. And also, the other thing that is, I find, even many investors, many people that come asking for money from investors, so what they say is that, I'm going to create this thing, and this is going to fill a much needed gap at Google or Microsoft, and so they'll buy it. So our exit strategy is to start this company and be acquired by Microsoft or Google, right? So how many people have you met who have a plan like that? But many people, right? So because they say, I'm going to create a company, right? Then some of them are successful too, right? So like, for example, Google Docs. Google Docs was originally, I think it was called Writely, right? So a bunch of people got together, said, well, I can actually create an entire word processor with 99% of the power of Microsoft Word, Well, it's not, it's because 99% of the power of Microsoft Word is what most of us need 99% of the time, right? So Microsoft, that's one of the gripes I have with, a big package like Microsoft Word, is that 99% of the time I'm using word processing. I just want to do get in and get out like VI. Okay. So I don't want to be, fire up the program, wait 10 seconds for it to load up. And because, this is a simple change. And I thought that, that's what everybody does. So why should I download this 15 gigabyte program that's going to check online for updates every time I fire it up? It's a pain if I just want to change a T to a D, right? And I'm pretty sure that's exactly what other programmers felt too. Yes. And so some bunch of really brilliant guys like you got together and said, well, you know what, these days, because now we have REST, this is all after REST came out and REST became popular, and saying with REST, I can make these things called AJAX calls. AJAX calls is where you can make a call over the REST interface to another computer running a web server and get the results back. So now that's there, now everything is taken care of. I can build an entire word processor, just like Microsoft Word, and offer it via JavaScript inside of a browser. However, it's not going to do these corner cases, right? So some really, really sophisticated stuff that most people don't even need. And that I'll leave to Microsoft. So from a Microsoft business perspective, now 99% of their use cases are handled by some online document or online document processor like Google Docs. There's 1% or 0.0001% of the use cases is what you really need Microsoft for. So from Microsoft's perspective, if they look at it from a business, with a business hat on, they're going to say, well, you know what, 99% of our code base is being maintained for a very slim fraction of the population of our user base. So I think we're also doing something wrong. So let's also develop a version of Microsoft Word that can just run off the web, yeah, without heavy duty stuff behind it, so that people can just go and make these dot the I's and cross the T's without having to do a great deal of work. That, I think, is how my Office 365 was born, because I think Office 365 is completely online, isn't it? Because just like Google, I can just go to Microsoft now and edit a document, save everything in OneDrive and things like that. So everybody has these things because with the cloud. I don't know how we got started talking about that, but but rightly. So they developed that. And then when Google saw that it was cool and it was useful, they said they just absorbed rightly and made it Google Docs, right? And a ton of Google services are like that, right? Some of them are developed by internal programmers like Gmail, Google Drive also. They were all developed internally, but a lot of programs were developed by brilliant people outside, and Google just said, we'll just buy them. Okay, where I was going with that was, so one of my friends, Chris, when he used to be a director at Google, and he was the person who led the Google Drive, Google Docs team there. And he said, a lot of people, this was a long time ago, I don't even know if this is still the case, a long time ago, he said, a lot of people think that, they can develop a company and sell it to Google or Microsoft or these big companies, but they have to look at it from Google's perspective. Now, maybe your company is successful and it is capable of generating, $10 million of profit per year. Okay, now that's not what Google looks at, right? Because when they say, oh, it's making $10 million a year, let's absorb it. That's not how they look at it. But from the developer's perspective, so $10 million a year, some big fish is going to swallow us, right? But from their perspective, they look at 10 million. But what is their bottom line? What is their revenue? It's in the billions. So what percentage of 10 billion, if 10 billion is 10 million or, something like that. It's very small. So it doesn't move the needle. It doesn't move the needle at Google. If we got that company, our total overall corporate profits are still going to stay here. So in order for a company to be bought by Google or Microsoft, you got to show that not only is my product developing, generating so much profit, but if it was scaled out at Microsoft scale or Google scale, the profits will also scale correspondingly. So it's not going to be 10 billion anymore. When it's integrated into Google, the profits will be 10 billion. Yeah. So then that is the reason for other companies will buy it. And that is another reason why when we develop programs, we got to develop them in a scalable way. Right? We can't develop programs with a view to just generating, X dollars of profit. Because it's X dollars given these resources, but we got to develop the system such that it is a function of the input resources, right? The output is a function of the input, so that when we throw more resources at it, without requiring extra coding, the same system is able to handle more load, right? And that is what other people are looking for. And so yeah, absolutely. After this class, after this course, yeah, or even during, right? You guys can, I would say, if you're interested in this kind of thing, also start looking into cloud and how to build systems in the cloud, right? And I think, one of you also asked me for pointers and tips about this, and it's fantastic. Okay, that's exactly what you should be thinking about, because C++ now, C++ is really the most powerful language you can ever hope to learn outside of assembler and machine code. Okay, so you have machine code, which only John von Neumann can understand. Okay, and you have assembler, which humans can understand, but not von Neumann. Right? Yeah, well, he also understands, obviously. Right? And then when you leave assembler, the next level up is C++. And C++ is almost identical to machine code and assembler, because when you code in C++, you know what is going on in the metal, right? So you know exactly what every electron in the system is doing. You can say, hey, electron, you're going the wrong way. You're going, right? That level of precision is afforded to you by C++, because you have control over every single thing. When memory is procured, when it's released, all of that thing, all of those things are available in C++. And so, yeah, so once you're able to interact comfortably with the machine itself on its own terms, speaking its language, the only thing you need now is you got one end of the spectrum. Now you got to nail down the other end of the spectrum. The other end of the spectrum is as far removed from the machine as possible. User. So you have the machine. I can talk to the machine. Now let me just take a break and figure out how to talk to users. And talking to users and talking to other services, that's another thing, right? So you get to learn the REST API, which is so simple, right? Anyone who has mastered C++, that is a piece of cake. So REST API is basically saying, this is basically the protocol I'm going to use to talk to different machines, right? When you send me a request, it's got to come in this particular form. That's fine, because I'm going to break it up out like that. Just like, double. If you take double precision in C++, you've studied data representation, right? Double precision, you got to know this is the overall 8-byte number, but of the 8 bytes, the rightmost 12 bits I'm going to use for the exponent, okay, and then the leftmost whatever's left, right, that I'm going to use for the mantissa. Right, and they're going to be used. They're going to be stored using 2's complement notation. Those are all decisions you make in how you store these things, right? And because you need to know that in order to interpret that. Because when someone sends you a double and says, "Hey, here's a double," how do you know what's in it? Right? If you say someone sends you 8 bytes and says that's my double number, right? So you got to. How do you know what's in it? So the only way you can know what's in it is to say, okay, this contains a double, so let me first break it up. That's the exponent, that's the mantissa, that's 2's complement. Then I can decode those things, and now I get 2.7182818 times 10 to the 0. Yes. So you have to decode it, but in order to decode it, you need to know how to break it up. So it's exactly the same thing when it comes to inter-process communication, right? When you send a message to another computer, another service, and say, here's a question, send me the answer. You're going to package the question in a particular way and saying, here is here's the address, one packet. Here's the address. Here's a question. Here's space for you to put the answer. Whatever, some protocol that's agreed upon by both sides. So you send the question, they'll fill the answer, send it back to you. Everything happens over the REST interface, and it's all ASCII too, right? It's not even binary communication. It's ASCII. So once you get a hang of cloud and how to develop services in the cloud with your C++, because once you also, if you know C++, Python and Java and PHP, those are very, very simple languages to learn, right? Because, here, a lot of people think, programming is hard and Java is hard and Python is hard and things like that. But we have to, I think, decouple the hardness of the concepts from the hardness of the superficial syntactic structures or control structures available to us. Now, the control structures available to us are different from language to language. When you go to Lisp or C++ or Java, they're all going to be different. They're slightly different, similar, but very different. Therefore, you may face challenges in saying, "Oh, I don't know how to do this in Java. I know how to do this in C++, but I don't know how to do Java." That's a challenge. Okay, easy challenges to solve. However, someone would say, "I don't know how to implement Dijkstra's algorithm in Java," right? Or I don't know how to, find the minimum spanning tree in this graph in Java. And so when someone says that, say, "I can't learn Java because, I don't know how to do a minimum spanning tree in Java." That is not an informed or a wise thing to say, really, because it's not Java that's a problem. It is their understanding of the algorithm, because the algorithm is going to be the same, whether they implement it in Python or Java or C++, it's the same. So even if they come to a language they know already and they try to implement minimum spanning trees, right, they're still going to face the same challenge. So many programmers, I find, sometimes will incorrectly put the blame, just like saying, the problem is not in my code, the problem is elsewhere. They say, I can't understand this, therefore the problem is with Java and not with the algorithm that I'm trying to understand. And so once you are completely conversant and comfortable with C++, all of these other languages, it's just learning the superficial, like Chomsky grammar, the deep structure and the superficial structure, just learning outside, and so because and learning the superficial structures is easier. So that's why once you I think if once you know what to say, you can say it in any language you want, because you are only learning the grammar and the syntax. That is why I think if I, suppose I move to China, right? So as I move to China in the next 10 years, right? And I don't know any Chinese right now, except for ni hao, right? So, but I go there but I already know how to think, right? I know how to think properly. So all I need to know is how to express these thoughts in Chinese. That'll be a whole lot easier than if I were to go there, not even learning, how to think or how to do certain basic things and then pick up the language. It's harder. So this is structures and so on, right? So what is aesthetically pleasing in that language versus this language? And because it's in poetry, for example, right? In English, usually when you think of rhyming poetry, it's usually the last syllables in the meter that need to rhyme in a sentence, right? But in Tamil, it is the other way around. So the rhyme and the meter is differently calculated. And Tamil is the language I speak at home, right? So the first syllables will have to, this is different. The structure is different. But that's all you need to know, right? Because once you go to a different language, you need to know what is aesthetically pleasing. What are aesthetically pleasing structures in this language, so that I already have the thoughts, right? And so I just need to boil those thoughts down. If you write crappy poetry in English, you're going to write crappy poetry in Chinese also, right? If you write good poetry in English, you're going to write good poetry in Chinese, because it's a same, superficial structures, but the deep structures are what people are going for. And so anyway, where I'm going with all that is that once you pick up basic cloud technologies, you can do a lot of things, right? Absolutely, really cool things. And in fact, if you complete my CS2C, right here, it's an open offer. Anyone, you can pass it on to your friends and other people too. Anyone who completes my CS2C, all 9 red quests, okay, I'm happy to teach a free cloud class, okay? AWS or Azure or Google is fine too, but I haven't worked a lot in those, right? I mostly do my stuff in AWS for historical reasons, but it doesn't matter. You just need to know one cloud and everything else is pretty much the same. Just need to learn, hey, how do I hook into the ML system at Google, because I know this is how I do it with Sage or in SageMaker and Amazon. Pretty much the same. So I will show you, right? I will teach you, and I'll also work with you to develop a simple project. In my cloud class, when I taught cloud in 2019, students had to create some really interesting projects, and they did, right? They did these really cool projects, and they demoed these projects. In fact, you did quest number 5 in blue, Eliza. So my cloud students had to develop a voice version of Eliza. So you'd be sitting at your computer and saying, hey, Eliza, what's up, right? And you'd be speaking it, and the system would understand your speech, and then it'll respond, just like Eliza in quest number 5, it'll respond, but it'll respond in voice, right? But all of that is being built just with cloud services. You're not building the speech recognition system. You're not building the speech synthesis system. All you're doing is that you're catching the waveform, sending it to your Poly service, right? I think Amazon calls it Poly. Send it to Poly. Is it Poly? I don't know, something else. I think it's called transcribe. Okay, you send it to that service. It'll turn that into text and give it back to you, right? And then you take the text and make your response from the text, and then say, I've got the response I want to send to the user. Now I'll send the text to, that's Poly, right? And then I got the text, I want to send it to Poly, and Poly will turn the text into audio as though someone is speaking it. And then you can get the audio and you can play it on the computer. So from a user's perspective, it's just like, I asked Google for a time and it told me what the time is. But that's what's going on in the background, right? So it's multiple services. It's not one program, multiple services, but Google has one end, like Adam's open agent architecture. It has one program that will receive these things and say, well, I've got some audio waveform coming in from Anand's Nest. Okay, so let's transcribe it, send it to our recognition system, get the results back. Now let's do some processing on the text because it's hard to process language, natural language with audio, right? So audio is always turned into text, and then Google will say, all right, I've got the text, now I'm going to process it, send it to my natural language understanding system, which is somewhere else, right? Maybe, you know, they're even located in different locations, and I send it there, and it'll get the results back. And then I'll say, okay, now I've got the results back, and I'm going to put the response of the user together. Okay, so this is the response that I've stitched together, needs to be sent back. But, you know, I can't show it because the command came to me by voice. So I'm going to send it to our TTS system, text to speech system, get it transcribed, turn it into audio, and stream the audio to your web browser, and the web browser plays it. Okay, now all of that happens. Even though I speak to Google Nest here, it is still, I bet, okay, it is still talking via an HTTP interface, which means that what my Google device is talking to, you can talk to from your browser too. Right? So from your browser, you can actually talk to the same server. I don't know, maybe they have firewalls and things like that, but I'm pretty sure that they're also using REST kinds of interfaces to talk between the different servers. Oh, maybe they have their own tailored way of, because when you have a service out there, and that is the difference, okay? So, and many people say, Apple programs are very nice, and Microsoft has a lot of fat built into it, and so there's too much more that I don't need. And but if you step back and look at it, they were conscious decisions, because the Microsoft family, the Microsoft paradigm said, we want to create a program that is easy to use for everyone. Therefore, I got to build in lots and lots of stuff into it. Account for corner cases, account for this population in Papua New Guinea, right? Who are going to speak in that particular way. So their programs tend to be fat. I got to talk to 1 million printers, right? Using 5,000 protocols. All of that has to go into their device drivers. So their programs are fat, they take a long time to load. Whereas Apple said, if we go that way, there's no end, because that is just going to keep growing as more and more people. So what we'll do is just say, we're going to have a closed garden. Okay, we will only talk Apple Talk to printers. We will only do this, only do that. That means they can focus more of their energies on what they can do. Right? Microsoft needs to hire more people, and you look at a lot more. Right? So even though the net brilliance or intelligence in both companies may be the same, it's just spread differently. And that is what we see. And how did we get talking about that?
Professor, should we start the class discussion since it's 10:45?
I'm sorry. Yeah. Go ahead. All right. Hey, I didn't mean to. Thank you. All right. Anytime I'm off like that, you should just feel free to tell me. Okay. Stop. All right. Go ahead and talk. I don't think anybody else is going to join. Okay. And if you need to talk to me, just call me. Okay.
Yeah, I actually had a question about cloud stuff. I can see a lot of the benefits are, but like, when do you think it's appropriate to use cloud versus not? Because it seems like there are a lot of things that are like talking to each other, which I assume would increase latency. So maybe it's like when you want something that is really fast, you don't use cloud or something like that.
If you have a program that only you're going to use, don't go to the cloud. But if you're developing a system that millions of people are going to use, then it makes sense to put it on the cloud, because it has to scale out. It has to scale horizontally. Scaling has two ways you can scale. One is vertical scaling and one is horizontal scaling. Do you guys know? Right? I don't want to talk about this now. All right. So a cloud system will be able to scale horizontally, meaning it can just take arbitrary number of users, just based on how many machines it has. And getting your program to a state where it is in that possible configuration, where I don't need to touch the code anymore. I just need to throw more machines at it. And that is where the cloud magic lies. So when you can get the program to that stage, you can say I release it into the wild in the cloud. Otherwise, just single user programs, best done on on your own IDE. Yeah.
Cool. Thank you.
All right. Thanks. No, I don't have anything else to say. Oh, doesn't make sense to me. Adam Stone. Well, hey, Adam, what is it?
I was just saying that, if you want to like.
Yeah. Could you? Yeah, because chat is.
I was just say the cloud services in the gaming area, or I mean, any concerns you have over latency.
Oh, totally.
It's like just incredible. It's incredible. Like Google Stadia, I think they do a lot of predictive stuff, but at the end of the day, it's incredible to like play like pretty proper games with no lag
Yeah, I didn't know.
running somehow
I didn't
through
know
your
about Google
browser.
Stadia. What is
Yeah,
Google
Stadia. Google Stadia is there. I mean, they might have actually canceled it. I know there was, Google likes to abandon things, and they may have abandoned it, but at least like 2 years ago, a year ago, it's a cloud gaming service that offers like games that are built to run on game PCs or PlayStation 4 or 5, and offers them through the Chrome browser. And it's just like unbelievably well done. And it's really hard to imagine.
Wow.
Yeah, I mean, we're talking like, we're talking first person games, moving around, demanding first person games being played with basically no lag over the browser. And in fact, one of the really popular games that came out for it was called Cyberpunk 2077. And the console versions and the PC versions actually had far more problems than the cloud version. So the cloud version for a long time was like actually the best performing version of it, which is, so it really kind of made me think the future is like really everyone's computer is basically like a console into a much larger cloud, because if you can run like these demanding games like that, it's hard to imagine what you need your local computer for. There isn't. It is like,
because like I'm sure Google has
Chrome.
like hardware that like they have to run it on some form of hardware, right? So like the hardware has to be somewhere, but it's not here.
Yeah. It's the cloud. Yeah, it's running through the cloud and through your internet connection, and it's it feels like a response time of 10 milliseconds or something. I mean, it feels like a proper gaming experience. So if we have any gamers interested in it, I mean, just the technology behind it it's like really hard to get your mind around that your computer is not running this game. So it's fun to mess around with.
It feels almost like it's running on your laptop, does it? Yeah. The reason I'm surprised is that they're doing it through the browser instead of having a plugin. Because a plugin, if you take plugins, you can do it, right? Because Unreal has this replication. Yeah.
Yeah. I mean, there must be a plugin involved. I must have downloaded it.
I'm saying not even a plugin in Chrome. Oh, I see, a plugin in Chrome. I see.
Yeah. So I'm sure it's doing a lot of, but it's still just like.
REST is fat, right? Because the REST interface is fat. And when you're doing a game in Unreal, for example, there's too much information if you talk via REST. And that's why I was surprised that they were doing it in a browser, because if they're using a browser they can't use REST. So they must be using some other protocol that is really, really thin. And sending only the bytes that are required by the other side, minimizing the header and the address and so on. And so for that, they can't use REST. So that's really cool. That is really cool that they've managed to boil it down that much. But still, because I remember back in the day, RuneScape. Do you remember there was a game called RuneScape? RuneScape. I used to play RuneScape with the downloaded client, right? And it was really cool. Yeah, it was fast and everything. It was downloaded, but it was using their program. Their program does not require the browser, and because it's their program and talking to their own RuneScape server, they know exactly what the protocol is, so they can minimize the fat and only send the bytes that are required. And it was really, really fast. I was doing that, and then suddenly at some point, I think, my son told me, this was before I got banned. Yeah, they developed a web version of it, right? They developed a web. You can play RuneScape on online in a browser, and I could see the difference, right? There was, even though it was pretty cool, there was these the lags and the jagged movements and all. So I'm very surprised that that's all been taken. Well, not surprised, eventually programmers will figure out a way to do these things, but really cool. Stadia. I don't know if it's still there. But Unreal is pretty cool. If you want to learn to do something in Unreal, after 2C, we can do a project using the Unreal Engine. If you have a decent PC, a decent gaming PC, we pick up a cloud project, or you can just say, I want to do a cloud with Anand, right? 2 weeks, I can just teach it to you for free in 2 weeks. It won't take you more than 2 weeks. If you completed 2C, cloud will not take you more than 2 weeks, right? I used to teach it for an entire quarter, like 3 months. But that's for students just coming in randomly and saying, I want to learn cloud, and they have no background at all, even in programming. Those people, 3 months. But you guys, after you finish 2C, you just need 1 week or 2 weeks, and you'll know everything. So I am happy to teach you all of that for free. Okay, you don't need to pay me money or anything. We teach you cloud, also Unreal development. Maybe you develop your first game. It's a very simple first game, in Unreal, and get started. But finish 2C, right? And then I will feel a whole lot more reassured that you will actually complete it and have some really kick-ass stuff to show in the end, and share with everybody else too. All right, thank you. I shouldn't take up any more of your time.
Oh, I have a question. I was wondering if you could explain segmentation faults.
Yeah.
Because I hit a bunch of them in Quest 4, and I was just wondering if you could quickly share an intuition for what segmentation faults are, and apparently you can also catch them.
Yeah. But don't catch them. You should let your segmentation fault kill your program, because segmentation, what it means is that when your program starts out, your memory, the computer's memory, is given to you in various segments of memory. Now, when you try and access memory that is not in your own personal segment, that is like reaching into my neighbor's home and grabbing a carton of milk from her fridge, and I'm going to take kindly to it, right? So that is a segmentation fault, and when that happens, the system will shut you down, basically kill your program. And it's not feasible. Suppose your program has 10 exabytes of memory RAM, right? It's not feasible for the system to monitor every single byte, right? Saying, oh, is it being accessed correctly and all? I think this is my theory. Exactly, I haven't looked into the recent architectures, but it is feasible for the system to constantly monitor just one memory address. So you can reserve one memory address as an illegal memory address that can never be allocated to any object, and say the operating system is going to monitor that address, and that is memory address 0, which we call null. So anyone who tries to access null, the program, you can be guaranteed to get a death sentence immediately. Bam, like that, right? And your program will predictably fail, and you can chase down the bug and nix the bug. Whereas if you didn't do that, then who knows, right? Maybe it's that program, that pointer is gone. It's pointing into Eileen's code, right? Eileen's process and somewhere in memory, and but I don't know. And so I run my program, and it accesses your memory, and the operating system will say, in fact, it may not be able to catch it because it's not null. So well, actually, if it goes outside the segment, it will definitely cause a segmentation fault. But if it goes inside of your own segment, where it is validly allocated memory, but it's not the right memory, right? Instead of accessing Y, you're accessing X, right? So those kinds of things the OS can't catch, but then it'll cause unpredictable, undefined behavior in your program. Maybe that'll cause some other error later on that will cause access to outside of your segment and cause a segmentation fault. So that's why memory errors need to be traced back all the way, and it's usually very hard. Not very hard. It is usually very. It requires a lot of not tedious. It requires a lot of thinking and work just to figure out where the memory error is coming from. Memory errors rarely. Well, I shouldn't say rarely. Okay, not always come from the place that they were generated in. Because chances are that if you access memory that belongs to you, but it's not the right memory, it's not going to cause a memory error right there. But it will cause a memory error later on because you changed a value that is not supposed to be changed. Your logic is all now screwed up. So you have no way of telling which part of memory you're going to access later on down the line because your logic is screwed up. So later on, you're going to access something that doesn't belong to you, and that's when you get killed. So that's why memory errors are harder to find. And one way in which you can minimize these things is just to make sure that any code you write that involves memory manipulation, just keep it really, really small, tight, and you can follow it through every single step of the way, and make sure that you cover all the corner cases. Right? With memory, especially corner cases are super duper important. What happens if this pointer is invalid? What happens if it's null? Right? What happens if if it's supposed to have 2 children and it only has 1? What happens if I should go down the higher but not the lower? All of those things, they're corner cases, and you have to be super duper careful. That is why quest number 4 is the first big wake-up call for many programmers. And once you cross quest 4, you're actually in a different league. Okay, because until Quest 4, you're mastering all the basics. Quest 4 is when you're trying to master the dance of, the art of dancing in hyperspace, right? Because the art of dancing in ordinary space, you know where all the steps are. You can put your feet there, you can label the floor, right? And do that 1, 2, 3, 4. Okay, but in hyperspace, in memory, you have no idea. But still your dances have got to be precisely choreographed. Yes, because your program will basically crash otherwise. So once you master the art of dancing here, you can, yeah. Sorry.
Are memory errors really challenging? Like, how often do memory errors appear in industry? Like, I know you mentioned like memory errors are really hard to trace back. Is this also a problem for software engineers working in industry?
All the
like
time.
All the time. All right.
All the time.
We gotta learn how to debug our memory errors well.
Totally. Okay, because once you start programming professionally, right, chances are that you will not see syntax and these basic kinds of errors, like in CS2A kinds of errors, you will not see them anymore, because those kinds of things just don't happen, right? When you're walking to trader joe's, you don't trip and fall randomly because you know how to walk, right? So once you start coding professionally after CS2B, even, right, even when you're in 2C, you're not going to be making those kinds of errors. And most of the errors, 90% of the errors that you encounter will be logic errors, more likely pointer errors, memory errors. So you will actually start getting better and better at tackling memory errors, starting from Quest 4, especially in Quest 8. Okay, Quest 8 will basically drill down memory. You got so many pointers lying around. You got to be like super duper sure where you put your foot down. And so in Quest 8, will make you totally comfortable with pointers. And once you cross Quest 8, you can feel very comfortable and saying, all right, I've gone through this forest of needles. I can go anywhere now. And then you can start looking at problems, logical problems that can be solved using the techniques you have, which involve manipulating pointers and so on, right? Because that's why when you do 2C without having a solid grasp in 2B and 2A, those people usually flounder. I've seen this so many times now since I even started offering questing. There are people who just directly enter CS2C. Now I just made it not possible. Okay, I said even if you enter 2C, you got to complete the blue and green quests. You see, for 2B you got to complete the blue quests, right? But 2C also I said you got to complete blue and green, otherwise you're not doing 2C, or you get dropped from class. And the reason I said that was mainly because I found lots and lots of students who were just enrolling in 2C, having done a very slipshod job in 2A and 2B, not in my section. They just did, they maybe did APCS and said, that's my 2A. And then they did a, low quality version of 2B somewhere else. It doesn't even have to be somewhere else, right? Any college you go to, you're going to find different levels of difficulty with different classes. Even at Foothill, I'm pretty sure that we offer sections in 2B and 2C that are far less challenging than mine. In fact, students have gone and complained to the administration, saying, no, Anand's section is too challenging, and these other ones we get A's, and it's much harder to even pass this class and shit like that. But this is everything I'm teaching you is part of what the state has decided, right? It's part of the CID. And that's what I'm teaching you. And I know this is the case because in the past, people have told me that, saying, oh, I entered this, but I did the class, but I was totally unprepared. And I did the class at Foothill. I wasn't prepared for this class. And then I followed some people who enrolled in my class and then found it hard and then switched to something else. Who was it? One student, this is 2C, one student I followed, dropped my 2C and enrolled in there's another 2C section that's offered. Mikhail McDaniel, I think, right? He offers a 2C section too. And his section is also very good, right? And he's put in a lot of work into developing his system for automatic grading and things like that, I think. But still, I think that is a less challenging version than mine because the student who dropped and went to that class, we had very similar assignments. So they took an assignment for which they got 20 out of 20 in his class. And they submitted it to the questing system after some minor changes, right? Exactly the same thing, but they didn't pass. It just got clobbered on, the third or fourth mini quest. There's so many errors in there. And the reason for that is because it is actually very hard to find all the errors in student code. And that's why back in the day when I didn't have the system in place and I had to get, printouts or electronic submissions of code, and I would look at the code physically and say, well, circle red, -2, -1, -3. You got 7 out of 20. That's why. Okay, but I would miss a whole lot of problems, and students would, and students wouldn't even look at the red. They just look at the number 7/20. That's all I got. Okay, and they wouldn't even learn, and same kinds of errors would get repeated again. But this way, everyone who learns something and gets past a mini quest, they will never make that error again, right? In later mini quests, this has been totally taken care of. And and that's the reason why, even if you, after you finish this and go on to another class, another school, Georgia Tech, MIT, Harvard, wherever it is, right? Look at multiple sections that are being offered for a class and find the section that is most challenging. Don't go for the easy sections. I go and look in the Foothill subreddit, right? Foothill has also got a subreddit, not ours, but there's a subreddit called Foothill, right? Or even on, some other sites. Students, I don't know why, students are always asking, this is the top questions, okay? Any course they want to enroll in, the question they ask is it an easy A? Right? How easy is it to get an A in this class? Why the hell are they asking that question? That is the stupidest question to ask if you're going to a college, right? You should ask, which class will I learn the most in? Because nobody's going to care about the A. Why do you care about the A when nobody else cares about the A? So our goal should just be to learn as much as possible. So we just need to go for the most challenging class, and don't care if your grade is going to be a C. I don't care if it's a C, but I actually learned some stuff here. Right? Whereas there, I got an A, but I didn't learn anything. What's the point? So always go.
A quick example of that is I paid a little extra to take some courses at ASU.
Oh,
they
I
have
see.
some
Yeah,
graduate. They have some graduate level computer science type courses, and they were like extremely easy. And
at ASU,
just how it is.
It's
Yeah,
not even
ASU.
graduate level. It's not even graduate level. They're like
Arizona
graduate.
State. Are you talking about Arizona State University?
Arizona State Computer Science Engineering Department. I took like 2 500 level courses, and they were just like pretty shockingly easy. And I mean, so easy that it's not just like an easy professor. I think it's like a philosophy of the department as a way of getting in money from distant students, kind of stuff.
I see.
But yeah, but just to your point, it's a total waste of money. It's just like what a terrible waste. So
it is a waste. You may see that happen.
I have 2 A's, but I'm
but
not sure. It doesn't mean too much.
Yeah. We do have at Foothill also there is a strong emphasis on increasing enrollments. And so we are talking all the time about how can we boost enrollments and so on. And that is one of the reasons why many people, I think, in administration would rather not have this difficult questing system and hand out more good grades so that we can get more students. And so that is a point of contention. And I say, I'll just retire sooner if it's compulsory that everybody be taught in that way. And so yeah, unfortunately, it is a battle between money and importing knowledge, and I recognize that. Yeah, fortunately, yeah, sorry. Everywhere, it's even at Foothill, But are you saying, Adam, that there were no other sections that were harder to? Because there may be other sections.
Yes. No. So this was like this is kind of heads up to other students, really, to be honest, because the classes are not cheap, but they're offered online, and they're a way towards working towards a master's degree.
How much does it cost?
I want to say $1,200 per class.
Wow.
And
even Georgia Tech is cheaper.
Is what it is. Well, Georgia Tech is the cheapest, to be honest. Georgia Tech is like
$700.
I've done a bit of research, and for distance courses, Georgia Tech program is like definitely the cheapest, and people are aware of it. But yeah, Arizona State, as I said, it really felt like a policy decision. So I took a knowledge representation course and a machine learning course. And
why would
I
was that much in Arizona?
Well, to be honest, I think ASU is a very business-oriented university, and they figured out that, especially if they open up enrollment globally, that a lot of people outside the US will do these distance courses. So there's a lot of Indian-based students that were taking these courses. And if you go into the subreddit and look up the the 2 courses I took were like amongst the most difficult courses. But your course is obviously much more challenging, and any of the free MITx type courses are much more challenging. So it's just just a good example of like you're spending money and you're getting grades, but it really, I just cannot imagine anyone benefiting. The knowledge representation class was good. It's an interesting topic and all that, but just in terms of the depth, especially machine learning, it's like nothing. So
I see. So there was a
I don't
student in
say.
my two quarters ago, there was a student in my 2B who also wanted to do something similar, but I think he enrolled in the Coursera course at Stanford. Andrew Ming, do you know the machine learning course? So I think he said it was really good value for money. I don't know if it may even be free.
Well, I think the
But he
money's
said-
zero. So.
Is it really free? Zero?
I think maybe Coursera charges like a little premium, but
Yeah.
basically
Wait,
zero.
for Coursera, I think you can take the course for free, but if you want like the certificate, then you have to pay for that. But like the knowledge is free.
Yeah,
No,
and
Coursera
honestly,
doesn't you didn't get a certificate with Coursera?
You get it
Okay.
if you pay for it.
Oh, I see.
Wait once.
I didn't know that. Yeah. I did one Coursera course a very long time ago. It was called Modern American Poetry. I didn't get any certificate for it. I didn't get a certificate, but there were a lot of very, very interesting meetings, but no certificate. But I know that some of the machine learning guys do get certificates, but yeah, I didn't know you had to pay for it. Wow. But now these days, there's so many courses, right? You can always pick and choose online and say, I want to do this. And you can look at all the forums. It didn't used to be the case. When I was a student, you had no idea what the class was going to be like. Because even the seniors, there's no easy way of contacting them, no email, and you have to go into the class and find out. These days, it's all so easy to do. So yeah, fantastic. Yeah, I'm very happy that you guys are in my section and also sticking around. And I do really hope to see all of you in 2C. And by the way, before I forget, I'm planning to organize a meeting with Rick Morris, who I think completed his degree at Georgia Tech. Rick is a senior student. He's already got a PhD in philosophy or something like that. So he wanted to learn machine learning or computer science, I think. So he did my 2A to B2C and then went on to Georgia Tech to do machine learning. And I think he's finished, right? Because it was like 2 years ago. So he said he's able to come and talk to us. And so I have Eileen, you're interested, right? Yeah. So I'm planning to organize a meeting with him in week 6 Wednesday. So that's 2 weeks from now. And it's not going to be, I'm not going to organize the meeting, but I'll tell Rick to organize the meeting on Zoom and then share the Zoom link with everybody. But I won't join the meeting, okay? And deliberately, I won't join the meeting because that way you can feel totally free to talk to him about anything. And only if you guys and Rick feel okay with it, he can share the recorded video on our nonlinear media channel, right? So until then, I'm not going to look at the video. So if you say something that you don't want me to hear, so you can say don't publish it, or you can tell Rick that before you send it to Anand, just edit it and get rid of 5-minute segment. I've done that, right? I've done that because when I'm coding with my 2A students, these 2A students very young and naive in many ways. So I say share your browser. They'll just share a browser. It's not a private browser. So it's got some crazy photos of their driver license and all. Right? And then that basically I got to tell them, now you just created like 10 minutes of work for me because I can't publish this until I go into the movie editor and get rid of those 5 minutes. And so they do those things. So you can make sure that Rick also knows that he doesn't have to. I'll tell him he doesn't have to share the video with me until it's all squeaky clean and you guys are comfortable with it, right? So, and also I won't participate in the meeting unless at some point someone send me a message saying, hey, we're done with personal stuff. Can you come and join our meeting? Then I'll click. I'll be there. I'll be here, but I won't join your meeting. Okay, so I'll do that. If anybody else wants to talk to Rick, just let me know. Okay, so I'll make sure that you're also, I'll just send me an email. So I'll say, there's 3 people from CS2A want to talk to him, right? So there's already 3 people and then Eileen and then any more of you. And I think it'll be fun because he had a good experience, I think, in class. and then he'll be able to tell you. Like Adam was able to say, OSU, ASU, you can also get some feedback about this class, this college, Georgia Tech, from him. The first
I
thing.
think Meng Yuan also posted a poll on the Reddit, and a lot of people filled it out. I don't know if you saw it. So I think there's a lot more people interested than have communicated with you. Because I saw like I think 5 or 6 people who filled out Meng Yuan's post.
Can someone just send me a list of email addresses, if possible, of all the people that are interested? Because that list I'll just send to Rick and say, when you got the Zoom link, send it to these people. Is that possible? Well, I don't want to, dump that task on you. But Meng Yuan, if you can look up your post and look at the results of your poll and say, these are the people.
I don't think we can see who it is. I don't think we can see who voted.
Okay,
Like,
then someone has just send me email, okay? And share this information with other people. But just send on in the quick email if you want to talk to Rick. And that's enough for me. And send an email outside of Canvas, because Rick doesn't have access to Canvas, I think. So I have to send him an email address like Gmail or Yahoo or something like that. All right, I'm so sorry, Chinmay. All right, so I shouldn't have taken up so much time, but you guys talk for the remainder of the time, okay? Later on, you can call me if you have any questions. And okay, all right. Thank you all so much. Okay, I'll see you next week. I think next week is the last meeting, unless you guys want another one. Okay. Bye.
2 more. There's 2 more.
Oh, 2 more. Okay, cool. That's fine.
Yeah. How are you guys doing? I saw you finished quest 5. And then you were like, it's so easy. Have you started quest 6?
Yeah, I'm doing my quest 6.
How far are you right now?
Just the beginning. I just
the beginning.
reading the material.
Yeah, me too. Me too.
Yeah, I think there's a lot to read.
Yeah, I like there's a video on YouTube. There's this one person, I think his name is Bucky, on like he does like C++ videos. He has a really good video on polymorphism. So I would recommend
Someone
that.
share the link on the
Yeah.
Reddit. I think
Yeah,
so.
I'll do that. And also, yeah, that's like my go-to video. I always go back to it, like watch it to review that concept.
I think there is someone who have shared the link on the Reddit. I don't know whether the people you talked about.
That was someone else. Yeah, that was someone else. How are you guys doing? How, Jim and Adam, are you guys like also wrapping up quest 5?
Yeah, I finished quest 4 late, so I guess I have to finish all the quests now. But yeah, I just finished it yesterday, so
Nice.
Yeah,
that was
same
cool.
thing. Same thing. I barely finished 4, and then I'm probably gonna try to bang out quest 5 today.
You
Yeah, 5
definitely can.
It's easy.
Yeah, 5 is really short.
Okay.
5 is very straightforward. I would highly recommend looking at the lecture notes that are on the website. There is a sample code that looks very similar in the lecture 2B website related to the exceptions and stuff. Because in the sample code, there's a class for like numbers and stuff, and quest 5 is basically the same. So
I'm actually confused about that. So what other resources do we have available to us? Because there's been some modules that have been linked, but is there like a more general website for the course?
yeah, it's in the syllabus, but it's only like it's like click here. It's like a smaller link.
Okay.
I'm gonna send it to the chat. This is the
That'd be
link
great.
for the lecture notes. I don't know if you've already been referring to them, but it was linked in the chat. Not in the chat, in the syllabus. But it's like very easy to miss. So I've been following this. Like I think if you go to weeks 5, throwing exceptions and nested classes, and the exceptions, the full listing, there is a sample for this class called rational, and it's very similar. It's very similar to our quest that we're working on today. So And also do not catch your errors that you throw in quest 5. I made the mistake of catching the error that I was throwing, and then I just crashed the program multiple times on the questing site. So don't do that. Just throw it and let it blow up.
Cool. Yeah, thanks for sharing that. I've just been using Stack Overflow basically, but this is probably a better strategy.
Yeah, I would definitely.
Did you take 2A with them?
No, I took 2A at UCLA. I also actually already took 2B at UCLA, but I took it pass, no pass. So that's why I'm back. I need a letter grade.
How do you like the class at UCLA while we're bagging on schools?
I actually, so from my experience, community college classes have been significantly easier than UCLA classes in regards to the standards. I would say this is the first class that I have ever experienced from a community college that is actually, I would say, almost equivalent to the rigor of the class that I took at UCLA, which I was like pleasantly surprised about. Because usually it's just like community college classes are, the bar is just lower. But this class is it's really nice. And I took it the first time, passed no pass. It felt like a blur. It was like during peak COVID, so it was just like everything was a blur. But I'm really glad that I'm able to come back and like reinforce a lot of these concepts. And I really appreciate sort of how rigorous it is. I feel like people should take this class rather than spend $15,000 on coding boot camps. Professor, I don't know if you're listening, but if the admin is worried about enrollment, you could just market it as a better coding boot camp, because people are dropping so much money on coding boot camps, and they should just take this class because it's way better.
So Alan, do you show your question of this and an arrow to the root? And is there
So
any
that was
reason
actually
to-
not the problem. I was trying to delete. So there was a variable that was like, so you know how when you do new, it's like on the heap, and if you don't do new, it's on the stack. I was trying to delete a value that was on the stack. I added delete this on one of the lines, and that was what was causing the error. If you look in the sort of thread under that post, the professor and I talked about it and we figured it out. But this is not this arrow was not the problem. I was trying to delete memory on the stack, and then it blew up the program. And then there was a segmentation fault, and it wasn't being like sort of forwarded out of the questing site. So that's what happened. But it wasn't this. It wasn't this arrow. It was something else.
Okay.
I still cannot figure out quest 4. Have you guys passed like the last couple of mini quests of quest 4? Because I do not know what's wrong. I spent like a ridiculous amount of time on the mini quest 10, and I just keep hitting a memory error, and I'm just like, I'm gonna debug it week 6, but
I don't know. I
Yeah.
just my advice is to check the edge circumstances to
because
look
the edge circumstances are like
no.
Like when that is null, right? If that is, yeah. So I'm checking that one.
When
you guys.
Yeah. When this is not null and when that is null, what the result is should be.
Okay, so if this is not null and that is null,
Yeah.
then I would delete this, right? And then I would assign null pointer to it.
Yeah.
Yeah, that's what I'm doing. You get like, go look at my Reddit post. I'm like, I really need help because I brainstormed as many edge cases as I could think of, and I cannot fix the problem. So I posted
a response to it. I don't know if any of it's right,
yeah,
but
I need to look at it.
To be honest, like I didn't actually think too much about edge cases personally. Like I don't think there's
you still passed it?
super. Yeah, I passed everything. No memory leaks. I got the full
What?
the full
Oh
deal.
my
I know.
gosh.
Very
Okay,
proud of myself.
I like have implemented every single tip that I have seen. So my I'm going to poke around outside of that function later.
Yeah.
Because I need to like do quests, like I need to stay on track. But man, that quest is really getting me.
Did you do I put it in the thing, but did you do the last one, the 13, mini quest 13, where you print out the?
I can't get to it because
config.
I can't pass quest 10. I'm like,
But-
I'm pretty
But have you
sure.
implemented it locally? Like, have you gotten 13 to work? Have you gotten the config function to work on your local machine?
Yeah, and quest 10 works on my local machine as well. And if you look at my post, like it's not even a memory leak. I'm just failing. I'm pretty sure I'm just failing one test case. I don't know where the error is. I don't know. I'm trying not to loop about it because I already wasted a lot of time staring at that one quest. That's worth like.
Do you guys know what is like the most difficult quest? He mentioned that there's one coming up that's more difficult than the others.
He said 8.
Okay.
8, and based off what he just said, it's related to memory, debugging memory. I saw there was a post somewhere, I don't know who, but they were just like that you can like install this and track memory errors on your own console. And I feel like I need to learn how to do that so that I can debug memory errors. Because right now when I hit a memory error, I'm just like, let me just look through my code and see what I can find. But I wish there was a way, like the thing that he uses on the questing site, like I feel like I should like install that and figure out how to debug memory errors.
I've looked into this. Maybe I'll try to make a Reddit post on it and get some other people's opinions. But there's a Linux utility called Valgrind that everyone uses for
Linux
memory.
Utility. Okay.
But I'm not running Linux. I'm not compiling on Linux. So there's a version in macOS called Leaks. I think it's part of like the standard tools, developer tools. But I don't know how to use it. I like looked into it. It seemed maybe a little more difficult than it was worth. But if you're running a macOS, that might be the one to look at. But I don't know. I couldn't. But I am using CLion. The debugger makes it really clear what the address of every variable is, or wherever the value of every
Visual
pointer is.
Studio does that for me too. So the addresses are different. I'm able to track that down. But
are they all in the heap? Are they all in dynamic memory?
Yeah, they're all nude properly. I don't know.
The reason I say that is because the major error I had in mind is that I was like creating, an allocation, and I was assigning it in this dumb way that the local object was actually in the object was actually local. And like I really, if we just glance at my
I made
code,
those mistakes before too.
And so, but so as a result, like I did create something on the heap, but it wasn't actually the object that I was interacting with. So that's where it's like, oh, okay, not only do the numbers need to be different because they were different in my case, we actually have to look at the value of the number. And so on my computer, for instance, anything that starts with a 7 is going to be in local memory, or we're going to be in whatever it's called. And then everything which starts with a 6 is in dynamic memory. So that might be worth looking at because
maybe I'm accessing a different object than I think I am.
Exactly. I mean, as I said, I was using new. I thought I had all my statements set up, but in fact, the way I was using new actually meant that the object that was being assigned was actually local and therefore had like local scope. So.
Okay, that's interesting. Thank you for sharing. I think
it's also interesting to look at.
Yeah, the professor telling us about how memory errors are the bane of industry engineers motivates me to be better at debugging memory errors, since that's going to be like what I not ideally, but like eventually paid to do, right? So I'm like, I really got to get good at debugging memory errors because then I could add more value to my team in the future. That like motivates me a lot. When I like very motivated by applications, and when I can see the connection to industry work, I'm like, okay, let's do this.
Well, shit, if you can get leaks to work, let me know. I can look into it too. But there is like a Mac OS version. That's all I can really say.
Yeah,
maybe I think it's actually integrated into Xcode, maybe. But I don't use Xcode.
I don't have a Mac, so I probably can't do that. But if I can get a memory error debugger to work, I will
Yeah.
definitely let you know.
Yeah,
because look
I
at
was gonna say the canonical one is Valgrind. That's the one that everyone uses in Linux environments. So you can search for that, and then it'll lead you to like, what is a Windows version of Valgrind? And I've used Valgrind before, and it's cool. It'll let you know. It'll tell you.
Yeah, I need to learn this skill, especially since it's never gonna leave us. Yeah, because I've been like, this is super tangential, but in OneNote, Microsoft OneNote, for a while back, they had like definitely a memory error because I kept getting like, I would try to load it on my console and it wouldn't load properly, and it'd be like error memory access. Like it would give like this really weird memory code. Eventually it stopped showing up because I'm assuming they debugged it, but I'm like, okay, these memory errors really ruining industry products as well. So it's very interesting. Jim, how are you doing? You look kind of stressed.
Yeah, I mean, I'm getting my butt kicked. I'm pretty much just pupping every quest, and then like I'm barely staying on time. But I mean, this is like my first time kind of being introduced to this kind of material, so it's a lot of learning I'm having to do. And like the 3 days between each quest, it's kind of like
do you wish you took it during the school year so you have more time?
Yeah, I think if it was like a 3-month quarter, this class would be much more manageable. But I mean, this summer term, it's pretty hectic.
Are you gonna take 2C in the fall?
Yeah, I mean, I'm gonna take assuming I pass this class.
Adam and Mengyong, are you guys gonna take 2C in the fall?
Yeah, I think so.
Yeah, if I have time. I mean, he seems like a great teacher. I mean, to be honest, like this is good. So he said I've paid a lot more for much worse courses. So yeah, this is good. Yeah. Oh, the other advice I had for anyone, I'm not sure if anyone's actually in this situation, but is like, if you take the free course first and then you take the paid course, you tend to do a lot better in the paid course. And
what does that mean?
Well, it just means like, if you're going to take algorithms at UCLA, for instance, do the algorithms Coursera course.
Basically pre-game your courses.
I mean, it totally changes the experience. So, for all these, I mean, like what he was saying was like, back in the day, you just didn't have these resources and the textbooks kind of sucked. So textbook, but now you have like proper classes available to you. So like whenever a challenging course is coming out, whether it's like Calc 3 or discrete, mathematics or like, whatever it is, you don't need to like suffer the way that you might have had to in the past, because like how else are you going to, learn it other than taking the course? Because it's like, oh, actually everything you want to know about algorithms is covered in, the Princeton course, and then you take for free on Coursera. And then you take the graded course at UCLA, you learn more anyway, because it's your second time with the material. You do better, you're less stressed. So it's just something that like
pre-game your courses.
I highly recommend if you have the time to pre-game.
My friend did that. My friend pre-gamed all his like honors math courses at UCLA. Actually, it's Obed. Obed's not even here. But he aced all of them because he pre-gamed all of them. Pre-game your courses, just like your parties.
And a lot of class success, I think, comes from people who've already been exposed to the topic. We can see it all the time, with your parents, with your industry, or whatever it is. So it's like you're basically giving yourself that pre-exposure that the top students have anyway. Like they are, they already are coming from these backgrounds. So it really doesn't make sense to step into it. So I took a course online through Harvard, and like you get some very prepared kids in those courses, put it that way. And you're just like, it's a totally, people are coming from such different levels that if you enter not knowing anything, the course is like the hardest thing you've ever done. You come in having already taken, 6 months of it. Okay, I can do this. So, and the reason I say Harvard is because there's so many kids that are so prepared there that like, it was very obvious that I was not, because like, it's like as hard as I worked, I couldn't make up the fact these guys had already taken the course, basically. And then a couple of them were geniuses, which also doesn't help.
Yeah, that's the case at most UCLA courses. If you don't pregame it, you're gonna drown. Because there's
Right.
no
But when
way,
I was
it's physically impossible to sleep enough to learn the material in X amount of time. I mean, Jim, you already made your bed, so you gotta finish this quarter. I mean, you can technically listen
Yeah.
and come back next quarter, but yeah.
Yeah, I mean, my main game, I'm actually trying to get into the Georgia Tech, the master program at Georgia
Nice.
Tech. So I'm trying to take this 3 courses because I come from a non-CS background. My BS physics, but I'm trying to switch over to computer science and like yeah, a lot of this stuff is real new to me. But yeah, so I was planning to try to apply for Georgia Tech for the next spring, but I think now I'm probably gonna delay it until next fall, like because of this class.
Yeah.
Yeah.
I mean, there's no rush. And I've also been lurking in the Georgia Tech subreddit. And something I learned is that Georgia Tech's like most people who get accepted to the Georgia Tech program don't finish it. Like, I think they have like an extremely high dropout rate because most people are not ready for the program. So I think I think you're not losing at all by waiting a semester, because the odds of you getting through the program, I mean, if that's your goal, are way higher if your foundations are stronger, especially because it's graduate
Yeah.
level and Georgia Tech is not ASU.
Yeah.
Yeah, I didn't mean to hate on ASU so much, but truly.
No,
it's the
I
worst.
mean, I don't blame you. I don't blame you.
I don't have any negative attitude towards the school in general, but like literally taking the courses and then going on the Reddit and being like, oh, these are actually the most challenging courses in the program. Guys, what are you doing? This is
Yeah,
terrible.
community college is better. Community college, or if you guys are in state, like you guys, I don't know if you guys know this, but you guys can enroll in like UCLA, UC Berkeley classes without being a student through concurrent enrollment. There's no unit cap. Like if you want to come to UCLA and take UCLA computer science courses, if you can get in, you can get in. There's nothing stopping you. Most people don't know this. Most people think you have to be accepted to take these courses. It's not true.
And Jim, I just sent him a book out into the chat that is like by far the best C++ book I've seen. So it's by the creator of it, and
Okay.
he's super chill. So he's kind of funny. He's like, why does C++ do this? He's like, I don't, it was like, we made a choice. I don't know. Like, he's like kind of like criticizing his own language. And it's a really good book. It's not referenced. He like presents code and then points out where it's going to fail and then makes the second iteration, points out that like, so he's like modeling the development process. So it's not a reference. It's an actual like.
Have you found a PDF?
Yeah. Yeah, it's easy to find. If you go to Legenesis, it's on there. I worked through the first like 10 chapters of it before the course. It's really good. And yeah, I mean, to be honest, this course would be really rough without it. So if you're looking for like a good fundamentals without it, I think this is like the best book, to be honest. So.
Do you guys care about UCLA CS lectures? Because if you guys are interested, I downloaded all the lectures. If any of you care about watching lectures, just like DM me on Reddit. I mean, do any of you guys care? It's basically this entire course, including CS2C, like a lot of the concepts in lecture form. From Professor Smallberg at UCLA. Yeah, I have it all in a folder. So if you guys are interested, here, I can actually probably just send the link in here. Hold on.
Is the first year UCLA all C++, or do you get to choose kind of like at the city college?
All C++. You do not get to touch Python. All C++. And then there is some of the courses are just notorious, really notorious. There's one professor. It's like you can expect 40 hours of work out of that one course a week. Some of the classes are really, really bad, but then that's also why a lot of the students succeed, and most are like the CS placements at UCLA are really, really good. Most of them end up in very, very good companies. Some first years are like 18 and they're like Facebook's, Amazon, Tesla, because it's so hard, which just goes back to what you were saying or what the professor was saying, take the hard courses because you'll land the better offers.
Well, and then also, as you say, Jim, like I did a lot of Python coding, like kind of more scientific coding, and it really did not translate to the algorithms course I took. So that's why I'm actually in this course, because I was like, C++ just addresses a lot of issues that you don't have to address in other languages. But if you only have experience in other languages, you just don't learn these concepts very well.
Yeah, I mean, I've had experience with Python before, like, I know how to like plot a graph and such, but it's like, this is completely like different stuff. Yeah.
Exactly. So that's why I find this book so good. It's like not really a beginning book. It's a little bit more like you get what's going on, but here's C++. But yeah, I got my ass kicked in algorithms course. But it turns out that like if you really do want to use Python, there are like high performance libraries you can use that make it much, much closer to C++ performance. So I didn't realize that. So I'm kind of annoyed as well, because I probably could have built some pretty fast algorithms if I.
Yeah, I mean, Python's the go-to language in interviewing. Like if you're gonna do like technical interviews, do not do it in C++. Don't make your life harder than it needs to be. Just do it in Python. Like that's actually the only reason I learned Python was for technical interviewing. People were like, why are you doing it in C++? Don't do it in C++, do it in Python, because it just makes your life easier. Also, I just shared the link to all.
I said it's just really strange because standard Python is so much slower than C++. I'm surprised.
Yeah, but in a technical interview, you're not testing for like that second difference, right? You're testing for your ability to communicate, your ability to explain complex algorithms, your ability to debug on the spot, and leak code and stuff. So I think that's why they don't care. I also just shared the lectures for all the UCLA, a link to a folder that contains all the CS lectures at UCLA. So if you guys want to watch UCLA CS lectures from the professor who teaches it, you can go on my OneDrive and take a look at that if you care.
Maybe in August.
Before CS2C pregame. There's like 2 months between the two classes. I'm like, there's so much time.
Yeah, it's a little weird. Mingwon, are you taking 2C?
Yeah, I need to take 2C. I'm gonna try to finish all the quests before the quarter starts, so I can just spend my time on the Reddit, get my participation points. Because if I finish the quest, then I'm just like, then I can just like chill and hang out.
You can do that in August, right? It's a good idea. You can work on all the you see in August.
Yeah, August through September, and then because it doesn't start till like end of September, so I'll see y'all in the 2C Reddit in August.
Sure. And Jim, did you finish Quest 4, or do you need any feedback, or are you good?
I pubbed it, but I'm just moving on. I mean, as of now, I've pretty much pubbed every quest barely, except for the first one. I think I got all the points for that, but every other I've just pubbed it and then I just started moving on to the next one. Like I haven't even like I even attempt to do the last mini quest. Like I just get up to the point where I pubbed and then I just move on.
I wish I could be like you. I need to learn how to do that because I spent like at least 20 hours just like poking mini quest 10. And then I think I got 2 people telling me, Ellie, just go do the next quest. And I was like, oh, I'm so itchy. I want to fix it. But that's a good skill though, being able to move on.
Well, I mean, for me, I kind of have to, or else I'm gonna fall behind.
No, I think you are not fall behind.
Well,
Because
yeah,
quest 5 is really easy, so you will finish it.
It's crazy because like if you look at the introductions, there was like I think like 35 people, and now there's only like I think less than 10 people on Reddit.
Wait. Oh, on Reddit. Because I was like, how many people are still in this class? I want to see.
Yeah. So,
I think the only way you can see is if you try to message people on Canvas, you can like see how many people you can actually message.
Yeah.
Those are all my thoughts. I don't think I have anything else. I don't
You
know if
guys
the
think-
professor's still there. Oh yeah.
I
the
don't
other
think there's
question.
gonna be a curve for the class, is there, huh?
I don't even know what the grading distribution looks like.
Yeah. Because I'm thinking I might just have to pop everything, and then I'm not sure. I don't think that's gonna be enough for an A. Might give me a B.
I mean, if you're really, really worried, then you could drop and take it in the fall.
I mean, I'll just
Uh,
take the B. It's not a big deal, but
But then what you can do, this is what you can do. You can do what you need to do for this class. Pre-game all the red quests through August and September.
Yeah.
That way when you start, you'll be good. And then you can like talk about that in your like Georgia Tech essay. Like look at my grade upward progression, right? Because they're like, it's fine if your grade is an upward trend. To be like, look at all of these things I overcame. It'd be good for your personal statement.
How was the
Sorry, I don't-
midterm?
No, I just got 14 points out of 20. What about yours?
Really? Oh, I got 18.
I
I felt like the midterm had a lot of, I felt like for the midterm, there was a lot of linguistic phrasing that I wasn't used to because I'm used to just doing it. So I was like, what does this mean? Because I know how to do it, but I don't know what it's called. So I had to like figure out what some of the words like definitions were. But yeah.
Yeah,
it was-
because I thought the midterm was gonna follow the quests more closely, but actually
I was
think it
preparing to
follows-
code.
Yeah, I think it follows the modules more closely.
Well,
Yeah.
I didn't realize there was a
So I was
midterm.
like, there was a
How did you
midterm.
guys know about- How did you guys know?
It was in the syllabus. You write it down in your calendar. It was on Thursday.
You didn't do the midterm? Oh, man.
I
It's
talked
only
to
20
my-
points.
It's
only
only
20
6%
points.
Talk to
of
the
your-
professor. I'll just
It's
see
only
what can be
6%
done
of your
here.
grade.
actually there's no notification. So
You
I
just have
just
to look at the
when I
syllabus.
wake up in the morning and I look into the canvas and I notice that, oh, there's a midterm exam, so I need to do it today.
The other course I'm taking, I just found out that like the professor's been emailing out practice quizzes and there's a Discord for the
Yeah.
course. So I'm just not very good at this. I'll have to email him right now, I guess.
Yeah. I
Yeah,
also
there was
looked
a
for the
practice
email, but
midterm too.
we didn't
Was it
get
really?
Yeah, there was a practice midterm. Like you could take at the beginning of the whole week this week.
Yeah, when
Okay,
I
well,
was,
the final is in 3 weeks.
let's just say when I was
midterm-
18, we barely had email addresses.
It's only 6% of your grade, and if you participate in the
I'll
Reddit,
talk to
you
him. I'll
get
see what
extra
I can do.
credit. But
Yeah, I'll
finals
see
in 3
what-
weeks on Thursday. Don't
Put it in
forget.
the calendar.
Okay. Thank you.
Funny. No one mentioned it in the Reddit, guys.
I'll post it in the Reddit for the final. I'll post it for you. Reminder finals tomorrow.
If you have just record, if you have Canvas set up correctly, do you get like alerts for this or no?
No,
I didn't get
I
no.
didn't get any
just for the
notification
midterm,
about
yeah.
it.
You guys are just
What
sitting
I
on top.
do is when every quarter starts, I have a table and I write down all the significant dates in the table. And that's what I do the first day of every single quarter. So I usually have every midterm and final date memorized like week 1.
You have
That's-
it.
Yeah, I've been doing this for like, I've been doing this table structure or this marking down structure for like 2-3 years. And it just helps me organize my brain a bit more. So maybe next, I would recommend that. Noting down in your calendar all the significant dates in the syllabus on the first day.
It's good advice. Yeah. Okay. Well, I'm gonna go send an email.
Professor, are you there?
I'll talk to him offline.
Yeah, hang on. Do you want me?
Oh no, I was just curious if
send him an
you're
email.
there or like if you're listening to us or.
I was planning to watch the recording later, so I wasn't paying a great deal of attention.
Oh.
But if there's something that, yeah, I'll absolutely watch the recording later on, though. But if you want me to answer,
Adam was like, we can talk now.
I have an
Yeah,
email
yeah,
to send
totally,
you.
totally talk. So, yeah,
I have an email to send you about my lack of organization. I'll do it over email.
Do you guys have anything else you guys want to talk about? It's almost 12.
Yeah. I'm gonna go.
Yeah. probably gotta go. Yeah. Were we
I'll
not gonna
see.
do lead code problems?
Yeah. I feel like everyone's got their hands full with the
Yeah.
with the quests. Like I feel like the lead code is like a nice. Oh, you guys should do Code Pass. If you guys don't already know about it, they're free technical interview prep. If you get into the advanced section, dynamic programming, greedy algorithms, and then there's a career fair afterwards to get you matched with companies. You should definitely do it. They have a class in the fall. It's completely free. It's technical interview prep. You guys should check that out if you guys don't already know about it.
Right, it was called Code Pass.
Yeah, I just sent it into the chat. It's free technical interview prep. It's a technical interview prep course. It's pretty cool. And you get like free mock interviews, resume support, career guidance, blah, 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 all those nice things. That's like my last comment. But I'll probably just see you guys in the Reddit next week. And
Yep.
Jim, I'm rooting for you. I bet that you can
Yeah.
do this next. I bet that you can go up. I have a feeling you can go beyond puffing this upcoming quest. I think you can do it. I think you can do it. I think it's doable for you. You can do it, and then build your confidence.
Yeah, because I mean, every quest has just been kicking my ass. I'm like, man, like.
No, this one's gonna be good. This one is a good breather. This one's a breather. Yeah, it was good talking to you guys. Professor, I think we're gonna hop off. We got a good
Okay, all
discussion
right.
in.
Thank you, Eileen. I'll get the record button in a couple of seconds.
All right.
Thank you all for
All right. I'll see you guys on Reddit next week.
Yep.
all right.
See you next
Alright.
week.
See you guys.
Bye.
Bye.